Hello and welcome to my video lesson 6.1 on similar polygons. So the main thing that we do look at in math is, I don't know why, but we really like triangles. So we will look at that at the end, and that is usually the focus in terms of how questions are written. However, I'll look at polygons in general as well. So to look at similar polygons, what that means is that they are basically one polygon is a smaller or a bigger version of the original. So I call them image and original. It depends on which one you're looking at first, but that's how I describe it. So if this is the original, then I call this the image polygon. So first thing to notice is to say that all the angles have to be the same. Okay, if all the angles are the same, then it'll probably be similar. And then you take a look at the next thing, which is if the sides are some factor of change. So in Math 9, you talk about scale factor, so that would be the term I will use. So here we have 3 on this side, whereas the corresponding side over here has 1. And this top side has 1, 2, 3, 4, 5, 6, 7, 8, 9. And this side has 3. The corresponding side has 3. So what you can see here is that our original side, whatever our original side is, times by our scale factor, which is kind of this adjustment factor, equals the image. There you go. No, that's not good enough. And the change here, if we want to take one of the numbers, is 3 times by something, some scale factor, equals 1. 9 times by something equals 3. Well, you can think about it as dividing by 3, or you can think about it as 1/3. So our scale factor is 1/3, which is the same thing as dividing by 3. All right, how about we flip it and do the original as the smaller value and the image as the bigger one. And although this is an odd shape, I'm going to show you 2 things to look for: the height and the width of it. So here the height is 2 in the original, and if I look at the bottom, we have 1, 2, 3 squares long, and this other one we have a height of 4, and the bottom we've got 1, 2, 3, 4, 5, 6. So to go from the original, 2 times by something equals 4, or 3 times by something equals 6. For them to be similar polygons, they have to be the same thing that it's multiplying. Otherwise, if they are not multiplying by the same scale factor, then it is not only enlarged or shrunk, made smaller, it's also being stretched in some way. And we're not stretching it. These are similar polygons. So 2 times 2 is 4, and 3 times 2 is 6. So our scale factor is 2. All right, this is more like a question that you would be asked with a triangle. And so here the triangles are not drawn to scale, so keep that in mind. But if they are similar, and the question would say that, they would say if, assuming they are similar triangles, find x. And that's not just circling x, that's finding the value of x. Whoops. So what we need to do here is find the scale factor first, and then find x, and then I'll show you one other method of trying to do this. So first of all, let's go from original to image. I like to do it this way. I always make the image wherever x is, because it makes it just slightly easier. So original to image, well, we know that 20 times by something, some scale factor, equals 10. And if you can do reverse bedmass or inverse operations, then you could just divide by 20 here, 20 here, and divide by 20 here, which means that you would get 1/2. So our scale factor is 1/2. So now that we know that, we can go 8 times by 1/2 equals x. And so that is like 8 divided by 2, which is 4. And so x equals 4. Maybe I'll do that in black. All right, I'm going to draw one more shape for you guys, or one more situation. Okay, so actually, yeah, I'm just going to go with ink to shape. One more situation. Don't worry about the, don't worry about the scale of them. Just assume that they are similar. And I'm going to write some numbers. And I would like you guys to find the x value, whatever is the missing side. Okay, so at this point, please pause the video and try this question yourselves. Okay, hopefully you paused and tried it yourself, and you're using this time to now check to see if you got it correct. This is another method. So that was scale factor. This is the final method, which is by using fractions. So what you're going to do is go x over the one side equals 30 over the other side. And so what you're doing is you're comparing the sides. So let's just show that. So this side is related to this one, so that's why they go up and down. And this side is related to this one, so it goes left to right. Or up and down on the left side, sorry. And so they're both, the change in them should be the same, and so that's why we can make them equal. Okay, now that we have done that, what we're going to do is just try to move the 8 onto the other side. Right now it's being divided, so we multiply. So x equals 30 times by 8 divided by 5. So 30 divided by 5 is 6. 6 times 8 is 48. And that is our value for x. So I hope this video helps you understand similar polygons a little bit better, and good luck.